Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the unit circle. What we're going to do is use this here called the unit circle to find exact values of sine, cos, and tan when the angle is more than 90 degrees. So we call this a unit circle, unit meaning 1, because the radius of the circle is 1. So this is a circle, its center is 0, 0 in the Cartesian plane and radius 1. So we divide our Cartesian plane into 4 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. So we're going to define theta, the angle we're taking the sine, cos, or tan of. It's going to be defined as the angle made with the positive x-axis. So I can draw a right-angled triangle here. I know it's right-angled because the x and y-axis are at right angles to each other. So sine of theta is opposite over the hypotenuse. The hypotenuse, which is the radius of the circle, is always 1. So sine theta is just y over 1, which is y. Cos theta is adjacent over hypotenuse. It's just x over 1, or x. Tan theta is opposite over adjacent, so y over x. So just to digress a bit, if I extend this radius here where it meets this tangent, this distance from the positive x-axis to where it meets the line, that's the value of tan theta. Obviously, tan theta can be more than 1. I just wanted to show you that. That's why it's called the tangent ratio. So if I'm looking at angles outside the range 0 to 90 degrees, I'm going to use this definition. Sine theta is whatever the y-coordinate is, cos theta is whatever the x-coordinate is, tan theta is y-coordinate divided by the x-coordinate. So think of this here as just a normal point in the Cartesian plane. So whatever the y-coordinate of this point is the value of sine theta. Whatever the x-coordinate is at this point will be the value of cos theta. So because theta is defined as the angle made with the positive x-axis, this here will be 90 degrees or pi on 2 radians. Over here, this is 180 degrees or pi, 270 degrees or 3 pi on 2. And back up here, 0 and 360 degrees, or 0 and 2 pi radians, are considered the same angle. This is what I mean here by period. If you add 360 degrees to an angle, you really don't change it. So for example, if I wanted sine, cos, or tan of 450 degrees, I would go all the way around to get to 360, and then I'd add another 90. So sine, cos, or tan of 450 is the same as sine, cos, or tan of 90. When you add 360 degrees or 2 pi to an angle, you don't change it. I know without using my calculator, say sine of 10 will be the same as sine of 370. Cos of 100 will be the same as the cos of 460. That's what all this is about. Now, tan actually does follow that rule as well. If you add 2 pi, you won't change the angle, but tan actually has a period of pi. So what that means is if you add 180 degrees to an angle, you won't change the tan of that angle. So tan of 10 is the same as tan of 190. Tan of 120 is the same as tan of 300. So these rules, the period I've listed here, and they are very important for when we come to solve trigonometric equations. So if you add 2 pi or 360 degrees to an angle, you don't change the sine or cos of that angle. If you add 180 degrees or pi radians to an angle, you don't change the tan of that angle. So the whole point of this is so we can come up with exact values of sine, cos, or tan for angles that are outside the range of 0 to 90 degrees. So let's say I want to find the value of sine at 150 degrees. How would I possibly do that? Well, what I'm going to do is I'm going to draw another triangle over here. So 150 degrees, I want the angle made with the positive x-axis to be 150 degrees. So of course, if this angle here is 150 degrees, this angle here will be 30 degrees. So let's look what would happen if this angle here, theta, was 30 degrees. So this triangle here and this triangle here, they would be congruent. They have the same sides, same angles. So this distance and this distance would be the same. These two distances would be the same, and so on. So it turns out if this angle here were 30 degrees, it would intersect the circle at the point root 3 on 2, which is about 0.866 and a half. So We know that sine 30 equals a half equals the y-coordinate and cos 30 equals root 3 on 2. So because these two triangles are congruent, this point here would be pretty much the same. The only difference is in this quadrant, in the second quadrant, the x-coordinate is negative. So this point here, where it intersects the circle, would be negative root 3 a half. So remember, the sine of this angle 150 degrees is the y value of this point. So sine of 150 degrees would just be a half, because the y-coordinate is a half. So what we do when we're finding exact values of sine, cos, and tan for an angle outside the range 0 to 90, we find an equivalent angle in the first quadrant. So let's say I wanted to find cos 4 pi on 3, which is cos of 240 degrees. So what would happen is I draw a triangle here. This angle here would be 60 because I want 240 the whole way around. It's 180 to here, so this angle would be 60. So cos 4 pi on 3 is very close to cos of 60. The only difference is at this point here, the x-coordinate is still negative. Remember, cos theta is the x-coordinate. But if I were to look at a triangle with 60 degrees, the x-coordinate would be positive. So what I'm saying is cos 4 pi on 3 is the same as cos of 60 degrees, which is cos of pi on 3 radians, except it's negative. Cos is negative in this quadrant because the x-coordinate is negative. So I know that cos of pi on 3 or cos of 60 degrees is also a half, so cos 4 pi on 3 will be negative a half. So let's look now at tan of 11 pi on 6, which is tan of 330 degrees. So if I want tan of 330 degrees, I could draw a triangle here. I want this whole angle to be 330 degrees, so this angle here would be 30. So the equivalent ratio is again 30. So tan of 11 pi on 6 is the same magnitude as tan of 30 degrees, which is pi on 6. Now the thing is, tan is positive in this quadrant. I know that tan of 30 is positive. Tan of 30 is just going to be y over x. It's going to be 1 on root 3. But in this quadrant, tan is going to be negative because the y-coordinate is negative in this quadrant. The x-coordinate is positive. Negative divided a positive gives a negative. So tan of 11 pi on 6 is the same number as tan pi on 6, except it's negative. So tan pi on 6 is 1 on root 3. So tan of 11 pi on 6 is negative 1 on root 3. So hopefully we can see a pattern here. In the first quadrant, all of the ratios are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. In the fourth quadrant, cos is positive. So you might remember it as all students take calculus or something to that effect. You need to know all of the ratios are positive when the angle's between 0 and 90. If you have an angle between 90 and 180 and you take the sine of it, it'll be positive, but the tan and cos will be negative, and so on. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.